let's run it. So the last figure should show us the time series now, very nicely plotted. Now notice that you see we didn't really specify how to draw the X labels, the X tick labels, but the PyPlot mechanism decides that it's because all these dates are all April 2021, year 2021. There's no need to print them over and over again, so it's going to skip all these, which is nice, right? So it makes the screen very the screen very clear, the chart very pleasing to read. Now we can also perform moving average calculations on top of our data frame, and it works only because the DF index has got dates on it, because moving average is specifically this rolling mechanism is to roll based on the dates, right? So here the moving average, we're trying to calculate the window size of 2, average up the past 2 data, then kind of do a forecast of the next day's data, like stock price, right? Before we know about the stock price. This is nice because if we forecast low, we might buy first and then wait for the price to go up and then sell, and vice versa. So the way we do it is to invoke the dot rolling, like I mentioned in the slide classroom version just now. Dot rolling is a bit like dot group by in the sense that it produces a semi-digested form of object, and it says, okay, now I know you are going to have a window size of 2, and you're going to process 2 at a time, generate a data, 2 at a time, generate a data in the new series. But how to process? What do you mean by process? What is that? What's the formula function that you want me to apply? And we haven't, up to this point in the highlighted command here, we haven't applied that function, right? And that function comes next and say, this semi-digested object, can you take in the average function and perform? So the net result is that it is always averaging 2 pieces of data stored in the new series cell. So once we have done that, we have a new series, all right, that is of the same shape as the original df.c. So remember this, what happens to the last cell? Last cell is fine because we can average the 2 data. The first cell, however, has got problem. We cannot see another cell before itself. It's the first. So it's going to get a NaN. And it is not unexpected. Even theoretically, we are expecting that. So of course, we will see. So now DF has got a new column, MA_C, which is the moving average, right, of what is it, C. So for example, we have 3 and 6. 3 plus 6 is 9. 9 divided by 2, 4.5. 3 and 4, 7. 7 divided by 2, 3.5. This is how we get it. But of course, for 6, one way is to sort of short circuit itself and say, oh, 6 is average with itself and we get a 6. But the theoretical way of doing things correctly is no, it's not defined, right? So we just leave it as NaN. So don't be surprised that you suddenly have this NaN there. And of course, we can also perform other calculations, right? We can do this here, exponential smoothing, right? And adjust equals to false, and we supply a dot mean to find the average. Now, what happens if we want moving average with a window size of 5? Okay, if we do that, then we can always do a 5 here, right? And that's all. So very simple. But if we want to do exponential smoothing, we'll use df.c exponentially weighted mean function. So it's not dot rolling because EWM basically takes into account all previous data theoretically. So what is important is that we provide the alpha 0.7, right? Adjust is false and then do a dot mean. And in combination like that, we end up performing the exponential smoothing. Okay, so let's just plot them and then we can always examine the resulting data frame. Okay, good. So not unexpectedly, we see this diagram. The C is the blue line, the original data. Yeah. The MA is the moving average. So we missed out one time period. The NA is not showing up as error, thank goodness, right? Because we know we didn't do anything wrong. And can you just ignore the net? Yes, it does ignore the net. Huh? So we get this moving average. And then we have exponential smoothing being done for all time periods, right? Okay, so let's check out on our DF like this. Yeah. Okay, so um, that's really nice. That's really nice. And we find that the initial value used by exponential smoothing, because there are only always two numbers to be determined before we start exponential smoothing, the alpha, which is arbitrary, and the initial value, which is theoretically arbitrary. But here, notice that the EWN sets it automatically by default to the first value of the data. Okay, so what this means is yeah, we need to be aware of that, because we theoretically this number, this initial value, can be arbitrary. Okay, next up, let's look at our multiple plots. Okay, so up to here, we're going to print multiple plot dual y-axis. Yeah, so we set the volume. So this is going to create the kind of stock chart, price versus volume chart, right? Which is very, very nice and nifty. And we wonder how we can also do that professionally, right? So, so we see here that the index is the date. We want this date to go back into, we don't want to throw away, but we want it to be sort of shifted back, inserted back to the data frame as a proper data, and then reset the dot index to 0, 1, 2, 3. Can we do that? Very simple. Yes, dot reset index. Change DF directly. All right, don't make a copy of it. So once we do that, the column will automatically be called index, INDEX. So we want to change the name, and so we use rename. The column is to change the column that's called index and change it into days, capital D. So do it directly into DF. Once you have done that, we extract out. Remember, DF will still have A, B, C, D, max C, max E, S, C. So we just extract days, column C, and volume. Okay, and what's volume? Volume is B. Volume is B multiplied by 1,000. So just to pretend that we have 1,000 shares of transactions all through. So after that, once we have prepared our data frame to plot, that's called DF2 now, we are now ready to create a new figure. Okay, use DF2 as our source data, plot. Now, when we plot charts with dual y-axis, I think we can summarize as what? As three things. Okay, let me see if I remember. First, make sure that all the commands used have use underscore index equal to false. Don't, by default, use the index. Remember just now we never specify X, it's automatically the index. So here we need to say, don't use it. I will supply the X value axis separately, explicitly. Okay, so we say that. So number one, always use underscore index equals to false for both the commands. Number two, in the second command line, we need to do two things. One is AX equals to AX, because the first command line will generate the axis, and we don't want a new axis to be produced. We want it to be that same thing. How do we say it? We say plot onto the axis. This is AX equal the value contained in AX. So you understand why I use AX, because it's always AX. But of course, to disambiguate it, you can always say something like this and it will be clear. But after a while, you get used to it, you know it's very, very clear. All right, that the first AX is the name that is defined in df.plot to be the named parameter. You cannot change that. The second AX is our variable AX, which we can use. We can use any name we like, so long as this name is the same as this name over here. Now, third thing that we need to do is to have secondary underscore y equals to true. So this is necessary, otherwise we won't see the volume labels which have different scale and starting point, ending point as the price. So once we have done these three things, we will get the nice chart, but it will not have the X labels, more specifically X tick labels. So what we do is AX, which is the new AX, that means the one that is uh, being overwritten with two charts, right? The new AX is going to be asked to set its X tick labels with all the days. Okay, the days, remember we have the days are the dates, the days of trading are the dates. To print this is a bit unwieldy, very long. It will make the axis very fat and a lot of whites there. So since it's a short date range, we can remove 2021 dash and then show it as 04-08. And so we can do that. And so we say that series dot dt, the dt is a bit like dot str. All the date related commands and functions are put under dot dt. So if you want to extract the year only, so dot dt dot year. The month only, dot dt dot month. You want to format the time, date time, dot dt dot string f time. This is why we have this here. Yeah? So the string f time, we now want to show it as %y dash month, two digit day. If you want to show it as two digit year, then just put a small y. Right? In some countries, you don't want to show dash, you want to show slash. By all means, change. So let's have a run and see.